Yeah, first of all, thank you. Thanks for the section and to the entire SAP team and SAP team and the all the audience who have joined today. My name is Avnish Kumar. I am the founder and CEO of LivNSense. LivNSense is essentially means living intelligent in machine, and we focus in the industrial assets, performance, and AI-led outcomes for the entire process industry to the utilities industries. So what we are going to present today is about the transmission and distribution. Our solution helps the transmission and distribution networks to move towards a self-healing network of future. And I'll talk about the use cases. Some of it is already I briefed during the previous session. Before I start, let me quickly introduce about our startup. LivNSense, we started off in 2018, and we work across the value chain of Industry 4.0, all the way starting from the assets to the process engineering and the simulation for the energy resources, all the way from oil and gas industries to the utility industry. We are based out of Bangalore, as our R&D headquarters is in Bangalore, and we have sales offices across UK and US. And our core mission is about leveraging AI, ML, deep learning, and artificial intelligence to bring the business outcomes and help in improving the overall reliability and operational efficiency. That's what we work, and maximize the profitability for the industry. So these are our key goals. We are a 50-member team, and we have experience all the way from integrating sensors to the AI ML-led platform journey, working with the partners like SAP. And I'll talk about the brief, though we have already covered this, but let me just touch upon about what the India T&D industry challenges is and why some of these use cases we are talking about makes relevance here. So to start with the current this is the left side of the graph gives you the fossil fuel based electricity, which is still accounts for 70% of the energy generation. And these are all centralized energy generation plants. And essentially what it means is that we need to have longer transmission and distribution network to distribute the electricity. Now coming to the entire AT&C losses at all India level, this is the figures I have taken from the Ministry of Power. So it's all the, you can also look into this data. The FY 2019 was 22%. Now ICRA is estimating that this year it will be 30,000 crores, and next year, the current FY21, it is going to be 50,000 crores. So that's what the data point is talking about. And the only way to minimize is to start the journey of AI and IoT to improve reliability and efficiency of these networks. That's the only way we can do it. Otherwise, we are almost more than double what global average losses are today. And this is what I'm trying to cover, and that's the problem statement I wanted to share. And let me just quickly go through how our solution can help this journey. What we are bringing in is the AI-driven improved reliability and efficiency. What I mean by improved reliability and efficiency, I'll explain it through our use cases. But what we are targeting is, even if we are able to target 10% reduction in outages and the faults, which happens across the distribution lines, all the way from the consumer to the substation, the improvement or the financial impact can be in more than 20,000 crores, and that's what we are looking at it. That is what we are doing. So we are starting. Stage one is starting from the smart meters, that is asset performance, and that's where we are doing the real-time asset performance management. That means I talked about that we are going to hand how to manage the smart energy devices, because that's very important. Collecting the data and using the data for doing revenue analytics, because in India we do have challenges of meter tampering to pilferages. So identifying the anomalies on data patterns, early identification of the power outage, and reducing the restoration time. Today, restoration time is almost in a couple of hours, and I'm talking about the larger cities where it is in few hours. But we need to get down to less than 15 minutes or even to few minutes for restoration time. That is what. And two-way network communication is another thing, because today the communication is also posing a challenge to reach out to. Even though you have a smart metering, if the communication infrastructure is not proper, we are not going to have an effective outcome here. Then second stage is the distribution performance, the DTRs, where the overload protection, the voltage profiles, and failure prevention is very critical. AI vision can play a bigger role here, specifically because of the nature of the distributed transformers, and specifically in the forest area to the rural areas where accessibility is a challenge. And identifying the technical loss analytics, specifically at the feeder, at the DTRs, at the power transformers, and coming up with a holistic reduction strategy. The other aspect is how do we do the load forecasting? Because whatever I did is by talking to a few of the substations in India, we still figured it out. Today we do a one-day in advance of load forecasting on a paper trail basis still. How it can be automated. And third aspect is finally moving towards the network performance, where we integrate DERs and bring the health monitoring of the DER, improve the energy, and we bring the on-demand energy management from there. The other aspects is definitely the power quality, the CVR, and the DSM part of it, the whole demand side management strategy. If we can follow this three strategy, what we call, or the technology is having multiple terminology, but we call it as a self-healing network journey. And this is the three stage of journey we are talking about, all the way starting from assets to distribution to the distribution network level performance. And just to start with the first use case, the real-time asset performance with the AMI, what we are offering here is the AI-based forecasting and revenue management, including the distribution loss analysis by collecting the data from the various energy meters here. So the challenges is like today, uneven loading of the network leading to the grid imbalance, inability to identify the energy theft, which is where the most of the losses happens, and then meter tampering and the connectivity losses. The connectivity losses still continues to be a major part. And what we are offering here is AI-based distribution loss analysis. We are offering the whole revenue management solution as well as the data analytics for the system load management. So what you can see, it's a platform which has got multiple solutions for the energy use cases, but this is what is the AMI analytics, we call it, where you can see the critical KPIs dashboard at a consumer level, at a specific sub-location to location level, or a substation level, or within a particular transformer. And even you can relate the data profiles with the transformer to see that whether the transformers are being not overloaded or underutilized, even we can figure it. It can be also be combined. The VADA for data is also combined along with it. So you can see that whole performance and the various analytics, including the power curve analysis. This is another important aspect where we are also giving comparative analysis, because time, day-wise, month-wise, annual, season, and eventually helping to identify real-time anomaly detection and prescriptive analysis with one single video. So you can find our solution can help with pattern matching, can discover the anomalies in the various smart meters. We can look at the average versus benchmarking versus the any kind of sudden rise or in the energy usage, which can give us indication of any kind of pilferage happening there. And you can do further deep dive into this data, and you can figure it out at what point of the day, what particular seasons this is happening, so that there can be an effective strategy for controlling these pilferages and identifying also the faulty devices or faulty meters and replacing them in the right time. That is what is we are working on. We are doing the various solution in the AMI side. Coming to the distribution asset performance, which is the key asset, is the distribution transformer, the power transformer also we are addressing. One of the key challenges with this is today DTR assets for a medium level discom is more than 10,000. It is practically impossible to, with a limited manpower, to manage the maintenance and inspection of all this. And that is one reason we find that there is always a frequent failures, and we identify those failure only after it has happened. So it's almost 10% is all official figure which is reported today, the failure rate of the transformer, but in my view, it is more than 20% today. And DTS, the other challenge is the installed area is quite large, very time consuming activity to really go get to the because the climbing up and then seeing the actual performance. So what we see, there are multiple solutions which we have come up with. One is the drone-based solution, where it for the remote and rural areas or the forest areas where electrocution of the even animals are happening, like in Bandipur, you can see that there have been always cases reported for such electrocution because of this one. And this is all happens because we don't have a drone-based solution, which is very easy to do. Fly the drones for a couple of hours, get the complete transmission line to the distribution distribution transformers, health monitoring, and report it on a real-time basis. We have been able to do some use cases here, and we have been able to figure it out that with inspection, a regular inspection or periodic inspection using AI-based drones, we can actually reduce the improve the maintenance cycle from a time-based to a need basis. And actually, today the failure rates, which is almost like, as I said, 10% official figure, can be brought it down to 1 to 2%. That's what we can bring it. And the other thing which we are doing on IIoT side, this is what is our digital twin of the transformer, which you can see that you can get a complete, or with the sensors, we can get a complete and real-time view of the transformers. You can see the oil temperature, which is most of the common failure points, and winding temperature. You can just go select the location, select the transformer. You can see the area where it is there, how many alerts, the oil and the number of oil temperature trips. You can figure it out, what is the voltage profile, current profile, and the trip events which has happened. You can even note the time, stamp, and all, so that you can very easily identify where the maintenance is required, where manpower needs to be focused. So it's very easy to do this and get to the condition monitoring and predictive maintenance of these transformers. That's what we are offering to. Now coming to the third use case, which is we are talking about now moving towards the network side, the network asset performance. And definitely DERs, specifically when it comes to DERs, I would like to focus more on the solar. Solar is very important source of energy and generation. But what is happening today, the average capacity utilization is not more than 20%. And that is where we believe there is a huge potential to bring this DERs and integrate it to the substation. But the challenge is the frequent issues in terms of the health monitoring of these DTRs. And that is where we are again offering that drone-based vision system for fault detection, classification, and quality checking for this large spread area where the solar sites are there. And we can also do the hotspot identification, isolate the stream, overheated cell elements. In fact, what happens when overheating of the cell elements happens, the voltage profile will come down, and then we need to switch on the fans and all to bring some cooling effect, etc. So this is what we are bringing in terms of computer vision. But again, like in transformer, we do have a complete IIoT solution for solar plant. And you can again get an entire solar plant view. You can go and look into which particular under which utility, which particular this one, how many arrays are there, how many are working, how many are faulty. You can even get the imaging analysis done from here, and we can look at the panels images, and we can do the AI vision based predictive and prescriptive analysis, and we can identify the ambient temperature, panel temperature, the voltage, current profile, and very easily we can figure it out from here, predictive how many number of failures could happen in an indicative warning, as well as the failures patterns of this, the power produced from the solar plant, the voltage, current, and temperature profiles, and eventually it will help to improve the solar PV efficiency. That is what is our goal and how we can utilize them better. So this is what we are offering, the various solutions. There's another one which recently we started working in the transmission line monitoring, because this is, I talked about it, like the electrocution which is happening specifically in forest area, rural area, where the the growth of plants and vegetation happens very fast, and it starts touching the transmission line. It is very dangerous activity also. So here again, we can use our drone-based solution for visual inspection, and we can do a complete vegetation analysis so that we can take the right action for the maintenance rather than waiting for any of the eventuality to happen here. And again, here also we do have the sensor-based solution as well to bring some of the data to do a complete real-time view of all the transmission assets, power curve analysis, and eventually this entire solution can get integrated to the upstream with the substation SCADA systems and bring an overall distribution losses analysis and give a predictive and prescriptive reliability monitoring. And this is what the platform is all about, which we have been integrated onto this SAP Industrial Cloud and SAP Edge services we are leveraging. We can connect any of the energy devices from starting from a smart meters, whether consumer or industrial consumer, to substation SCADA system, to the various DERs which can be integrated, and it provides a microservices based various services, and we can and it can be incrementally built for the journey towards self-healing, which is what we are offering. This is just one example of how this whole self-healing can be brought by this AI agent, which can help in the optimum energy optimizing the energy losses and improving the overall operational efficiency and reliability. And this is how the journey can be done. It's a crowded slide, but just to give a perspective of the platform and maturity which we have got in distribution and transmission, how we can take a phase-wise journey. I showed you some of the use cases which can start in phase 1, and eventually we can build a complete strategy for the utilities and discoms from a self-healing journey perspective. And coming back to our the 3-stage operation, this is what the business outcomes we can see in each of these stage. At least this asset performance itself, we can start containing up to 15 to 20% of revenue losses. And in stage 2, we can add further by reducing the O&M losses by 5% and 10% improvement in grid reliability and efficiency, including the critical parameters like SAIFI, SAIDI, all those we can improve it. And this is what we are offering as a solution. And overall, I can say that even in 1% reduction in distribution losses can result to almost 50 billion rupees per annum basis at an all India level. And that is the opportunity we're talking about. Thanks for your time, and